This video is on forces and elasticity. This is for the theory. There'll be a later video on the required practical. So we can stretch objects. So for example, here I've drawn an elastic band, and this elastic band will stretch if we put forces in opposite directions away from one another. We can bend objects if we've got a pair of forces acting in the same direction and we have a pivot point or a point for it to bend upon. So for example, a pen, if we put forces both downwards, my thumb's making the pivot point and it starts to bend. We can compress, which is a scientific way of saying squash, if we put forces in opposite directions but coming towards each other. So if they're away, they stretch. If they're towards each other, the object will compress. For example, this spring, we can squash, we can compress springs by putting forces together. There's different types of elasticity. There's elastic, and that's where the object returns to its original shape and size when the force is removed. And there's inelastic, which does not return to its original shape and size when the force is removed. There's an equation that links force and extension. And extension just means how much longer it's got or how much shorter the object's got, the change in the length. And that equation is force equals spring constant times extension. Force is measured in newtons, extension is measured in meters, and spring constant is measured in newtons per meter. Like any three-termed equation, put the numbers into the equation first, convert any units, and then rearrange before you get your answer. If we plot a graph of extension on the x-axis, force on the y-axis, or vice versa, you could get a nice directly proportional line, directly proportional from the origin, going up in a straight line. This shows it would be an elastic deformation. That means it will return to its original shape and size. However, if the line curls up, or curves down, or plateaus, that shows it is inelastic. That's an inelastic deformation. There'll be more on this in the elasticity required practical video. And the equation that links energy, so for example, if we squash, if we compress a spring, we're going to store energy in that spring, elastic potential energy. The equation for that is energy equals half times spring constant times extension squared. And do not forget the squared, people often do. And these two equations are very strongly linked. So you could be asked to calculate the extension using one of these equations, then find out the force using the spring constant. Or you could be, for example, given the extension, asked to work out the spring constant using a force, and then you put it in to this equation to calculate how much energy is stored in that spring.